Hello there. It's time to use our knowledge of sine, cosine, and tangent ratios to calculate some unknown lengths and angles. So step one in these problems, in this given information, get a good picture to look at. There's a 90-degree angle. I'm going to draw a right triangle. So this 90-degree angle down here, this is going to be angle C. And my next angle is a 20-degree one, so I want to have a fairly accurate picture. Big angle, small one's going to be 20. And that is angle A. And the last angle up there, I guess it doesn't specify, but we'll make this B. And the length that it gives me is length C, and that is opposite angle C. Has to be. So this is C, and that's going to be a 10. And then I have these unknowns in here. So first unknown is this angle, and then I can just subtract 180 minus 90 minus 20. This is going to be a 50-degree angle right in there. And now I want to know these lengths. So I'll call them like H and B. So I guess I shouldn't call it B. Angle A opens up to it, so this is side length A. So let's start with A. Side length A, I don't want to do a ratio that compares an unknown with another unknown. I want to compare an unknown to a known. So I want a trig ratio that involves A and the known 10. Then I have a choice. Do I work from the 50 or do I work from the 20? I'll work from the 20. So the 20 opens up to the A. So that A is considered opposite. And this is going to be a sine ratio. And the sine of that 20 degrees is the opposite, A over the hypotenuse 10. And this I need to solve, so multiply through by 10. Evaluate this, make sure your calculator is set to degrees and not radians. And round to 2 decimal places. Okay, so that was A. And now let's give ourselves a little bit of space for B. I'm still going to work off of the 20, not the 50 there. Now B's relationship to the 20 is it's adjacent, and the known is still the 10. I actually could work with A over here, but this was rounded, and I don't want to truncate my answer, so I don't want to deal with a super long thing in exact form. I'm going to use the original known, the 10. Adjacent, hypotenuse, this is a cosine ratio. Always set up your ratios. Cosine of 20 degrees is equal to the adjacent B over 10. Multiply through, and solve. Rounding to 2 decimal places, this is simply 9.4. Even though I'm only showing one, it's actually accurate to 2 decimal places. This gets bumped up. I could also do the Pythagorean theorem, this squared, 10 squared minus this squared, take the square root, get that. That would work too. Okay, next one, get a picture. So there's my P and a Q. This down here is going to be angle R. That opens up to side R, which I know is 7. And this angle down here needs to be complementary to the 55, so that's going to be a 25-degree angle. Wait, is that right? Yeah, that's right. No, that's not right. Not 25 degrees. 35-degree angle. Yeah, that's complementary. Okay, so I got the unknown angles. This over here is going to be side length Q. This over here is going to be side length P. And I want to relate them to the known length 7. So let's start with this one, Q. From the 55, the Q is opposite, and the known is adjacent, so this is going to be a tangent ratio. Multiply through by 7, and evaluate. So rounded to 10, 9.997, 2 decimal places. We'll bump that up to a 10. Okay, next one. I could change to work with the 35, but I kind of like working with the original 55. This length could do the Pythagorean theorem, of course. P is the hypotenuse, it's opposite that 90 there. The known one is adjacent, so this is a cosine ratio of 55. And that's going to be adjacent 7 over the hypotenuse P. This one's trickier because the variable I'm interested in is in the denominator. So I gotta get it out. I'm gonna multiply both sides by p. If you're dividing by p, multiply by p. Undo it. And then to get p by itself, I'm gonna divide by cosine of 55. This I can type in and evaluate. Alright, there we go. And that is longer than the other sides. It's important when you're doing this style. We'll just circle all these final answers here. Bum, 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 bum. These are the lengths. Of course, I have the angles over here, down here. When you're doing this type of problem where it's in the denominator, it's really easy to not divide and get it wrong and do 7 times cosine of 55. That would get you a hypotenuse that is shorter than the legs. So this 12.2, if this is 7 and this is 10, this has to be longer, and 12.2 is, so I would get immediate feedback if I had like a hypotenuse here of 6 or 9. Alright, thanks for watching. Character Scholarship for Life.